all, welcome to EC Electronics. This is a video on ISRO Technical Assistant exam preparation, and we are going to see the questions from microcontroller and microprocessor. So this is the part 2 of microcontroller and microprocessor subject. So let us see what is the first question for today's class. Which locations of the internal RAM are reserved for special function registers? So here we are talking about 8051 microcontroller, and out of which of the locations are, or the memory locations are being reserved for the special function registers. Option A 80H20FF, option B 70H20FF, option C 90H20FFH, D 60H20FFH. So out of this memory locations which is reserved for special function registers? The correct answer is option A, which is 80H20FFH. Now, if you see the architecture of 8051 microcontroller, it consists of internal RAM of 256 bytes. 256 byte internal RAM is present, and 4 kilobyte ROM, which is extendable up to 64 kilobyte ROM. That is, externally you can connect 64 kilobyte ROM, and internally there is 4 kilobyte ROM present. So here we are talking about the RAM, because the special function registers are present inside the RAM or the internal RAM, and the RAM is 256 bytes. This 256 byte is divided into two portions. In the first 128 bytes, there are general purpose registers. I'm just giving you an introduction about this question. Okay, so general purpose registers are present, and in the next 128 byte, there are special function registers, of which we are talking in this question. Special function registers. Now the memory locations for this first, that is the general purpose registers, are from, the first one is from 00 to 7FH. Okay, and the special functions, that is the second one, is from 80 to FFH. So this is the memory location, that is the second one, reserved for your special function registers, which has been asked in the question. Okay, so this is an overview about the internal RAM of 8051. So the correct answer for this question is option A, which is 80H20FFH. Okay, so this is 0FF. So the correct answer is option A. Let's see what is the next question. What kind of instructions usually affect the program counter? Option A, call and jump. Option B, call and return. Option C, push and pop. Option D, return and jump. Now, in this question, they are asking about some instructions, and out of which instructions are affecting the program counter. Now, let us see what are the options. The first option is call and jump. Now, what is a call? What is a jump? If the processor is executing some instruction, the call means it is a call to a subroutine or another program or a routine is called a call. So during this call, this subroutine is being called to your main program, and this instruction calling is exited with the help of return instruction. So that is, when a call is used, means whenever the processor is in need of some other routine, and the processor will call this routine to the main program, and in order to return from that routine, the last instruction is a return instruction, and it returns back to the main program. So that is happening in a call function. So in call, what is happening? A subroutine, I'm just calling it a subroutine, or a routine is being called, and how will it return from that routine? The last instruction is a return, and when this subroutine is being returned, it will jump back to the main program. So a return is used to return from this subroutine. So that is happening. So here we are considering that you are calling a subroutine. Now what is jump? Jump is actually a part of your main program. So whenever this jump is happening, the program counter will jump to that instruction. It will not return. So there is no return in jump. So it is actually a part of your main program where there is actually a deviation happening, and that deviation is a permanent one which is not a returning type. So that is a jump. Okay. Now I've already talked about call and return because they are happening together. So when a routine is being called, in order to return, we have to return from that subroutine. So return instruction is used. Then what is push and pop? So we have talked about call and jump. Now let us talk about push and pop. This is a very familiar word, I think, to all of you because it is being constantly used in all microcontroller related topics. Push means, see, we have already talked in the previous video, that is a part 1 of this video, that whenever some interrupt or some other program is requesting the service of the processor, what will happen? The processor has to stop the current execution and to save the current instructions or the current instructions address which is present in the program counter to the stack. That is actually the program counter is being stored to the stack in order to jump to that interrupt. Okay, so when the processor is executing some instruction in the current program. So while executing this line, that is the program counter is here. So an interrupt is coming. So what will happen? This program counter, that is the address present in this program counter, has to be saved to a stack. So that is a stack memory. It has to be saved to the stack in order to use it back when the interrupt processing is complete. So when the interrupt processing is complete, what will the processor do? It will go and take back this address from the stack and will continue the execution of the rest of the main program's instructions. Okay, so that is happening. So this moving of the program counter to the stack is called push, or inserting any element to the stack in general is called push. Okay, so here when we are inserting an instruction or a program counter address or program counter, it is actually a push. So that is a push. Now taking some elements from the stack is called pop. In general we can say as elements. So inserting of elements is called push and retrieving of elements is called pop. So that is push and pop. Okay. Now next one is return and jump. So return is actually used along with the instruction called call, and jump is something different. Okay, so these are actually the 4 options. Now we have to choose the instruction which is affecting the program counter. So that is actually your option A, which is call and jump. So whenever the call is happening or whenever the jump is happening, the program counter is jumping to that routine or to that instruction. Well, the case of a jump. Okay. But in case of a push and pop, what is happening? We are just storing this program counter's data, or just this program counter we are actually storing or retrieving for push and pop. So that is not actually affecting the program counter. You are doing something with the program counter. Okay. So that is push and pop. So the instructions usually affecting the program counter is call and jump. So you can also use call and return, but the more correct option here is call and jump, because both this are affecting the program counter. So the correct answer for this question is option. The next question is, which commands are used for addressing off-chip data and associated codes respectively by data pointer? Option A, move X and move C. Option B, move Y and move C. Option C, move Z and move A. Option D, move C and move Y. So the correct answer for this question is, if you have used this microcontroller, you will be knowing the answer. The correct answer is move X and move C. So how to use this move X and move C? So MOVX is used for moving data. MOVC is used for moving of code. So MOVX can be used like this. First move dptr, comma hash 4500 some address location, and then you can use the MOVX to move this value to the register A, that is MOVX A comma at the rate of dptr. Now this is how you use a MOVX command. It can be used in various other ways also, but in general you can use it like this. Now if we are using the MOVC, then it is like this: MOVC A comma at the rate of A plus dptr or A plus PC, program counter. Okay, so this is how you use a MOVC command. So in general, in order to access the off-chip data and associated codes, you can use which all commands? MOVX for data, and codes can be accessed using MOVC command. So that is a question, and the correct answer is option A. Then the next question is, which control signals is affected by timing and control unit of 8051 to access off-chip devices? So we are going to talk about off-chip access of 8051 microcontroller. Now the options given are option A, ALE, option B, PSEN, option C, RD and WR, and option D, all of this. Now let us talk about the options first. ALE is address latch enabled. I'm going to write it here. So ALE is what? Address latch enabled. Now this is a very confusing word actually in 8051 microcontroller. So what is this address latch enable doing? Let us clear that first. So we have talked already in the beginning of this video that we can connect a 64 kilobytes of a row externally, that is an external memory, can be connected to 8051 microcontroller. And if we want to access that external memory, we can use this ALE or address latch enabled. So how to use this? We know that the address of this external memory can be represented using the two ports, which are port 0 and port 2. Okay, so port 0 and port 2 will be carrying the address of the external memory, that is a 64 kilobytes maximum we can connect, and out of it some memory locations if you want to access, the address will be carried by port 0 and port 2. Now port 0 will be carrying the lower 8 bits and the port 2 will be carrying the higher 8 bits. Okay, so now let us talk about this port 0. This port 0, if you see the pin diagram of a 8051 microcontroller, the port 0 is represented as AD0 to AD7. Now what is this AD representing? It is representing that address and data. That means this port 0 can be multiplexed. That is, it can carry address and data. Now how to figure out whether the port is carrying address or the port is carrying data? This is identified with the help of this address latch enable. That is, this address latch enable is a high pin. Okay, high pin means it is active high. So if this address latch enable, that is ALE, is equal to 1, then the port 0 is carrying address. And if this ALE is equal to 0, then port 0 is carrying data. So that is why we say that the port 0 can be multiplexed, means it can carry both address and data, and this confusion is figured out with the help of the address latch enable pin, which is an active high pin. If the ALE value is 1, means the port 0 is now carrying an address. Now if the ALE value is 0, means now the port 0 contains some data. So that is the address latch enable pin. So one thing is clear, that this address latch enable is used for off-chip accessing or accessing of off-chip devices. Next is PSEN. It is actually PSEN bar. That means it is an active low pin. ALE is an active high pin and PSEN is active low pin. So if PSEN is set to 0, means external memory access is possible. That is, or if external memory access is happening. And if PSEN is 1, external memory access is not happening. Okay, so that is the function of a PSEN. Now the option C is RD and WR. So it is read and write bits. Okay, then the last one is all of this. Now in the question they are asking which control signals are being affected when some off-chip devices are being accessed. So all these signals are being affected, or all these pins are being affected. Okay, so the correct answer for this question is option D, which is all of this. Question is, which register usually store the output generated by ALU in arithmetical and logical operations? A. Accumulator, B. Special function register, C. Timer register, D. Stack pointer. This is a very simple question. For example, if you are adding two numbers, add A, B, then the result is stored in which register? In A register. Now A is what? Accumulator. So the correct answer for this question is option A, which is accumulator. Now let us see what is the next question. Which general purpose register holds 8-bit divisor and store a remainder for division? Now they are again asking something related to the arithmetical and logical operations. For the case of division specifically, which register holds the divisor? That is, only that register can hold the divisor and the remainder after the division. That is, for example, div A, B. Now, we are going to divide two numbers present in A and B. So, A is holding what? A is having dividend and B is holding divisor. Now, after this instruction is being executed, how will be the case? A will be having the quotient and B is having the remainder. Okay, so this is the case. So, after the execution of the division, A is having the quotient, B is having the remainder. And before division, B is having the divisor. Okay, so this is the case and the correct answer for this question will be what? Let us see the options. Option A register, then B register, register R0 to R7, D all. So B register is having the divisor and after division the remainder. So the correct answer is option B, which is B register. Next question is, default value of stack once system undergo reset. Okay, so default value of actually it is stack pointer when the system undergoes a reset. So we know that the stack is actually the register bank 1. That is, there are 4 register banks in 8051. That is R0, R1, R2 and R3. Out of which the register bank 1 is reserved for stack memory, or it is allocated as stack for the 8051. Okay, so let us see what are the memory locations. This we have already discussed in our earlier video also. So for R0, the memory locations are from 00 to 07H. And for register bank 1, it is 08 to 0FH. And for register bank R2, it is from 10 to 17H. And R3, it is 18 to 1FH. Okay, so 00 to 07, then 08 to 0F, 10 to 17, 18 to 1FH. So here the register bank R1 is used for stack memory. So when the system is reset, the stack pointer will actually go to the beginning of this R1 register bank. That is, if you see the diagram, it will be like this. 0 0 to 0 7, then from here to, that is 0 8 to 0 FH, then 0 F, that is next one, 1 0 to 1 7, then to 1 FH, likewise. So where this is R0, this is R1, this is R2 and this is R3. So the stack pointer will come and point to this location, because this, after this 0 7, after the 0 7, what is happening? The stack is starting. So it points to the location 0 7H, because it is actually the beginning of the stack memory. Or the register bank R1 is from R1 is from 0 7. So it points to, that is a stack pointer points to the location 0 7, because after which the stack is actually started. So after reset, the address location or the value of stack pointer will be 0 7H. Okay. So let's see what is the next question. Which operation is performed? I'll remove this. Which operation is performed by stack pointer during its incremental phase? Actually, we have discussed this question. Anyway, let's see. The options are A push, B pop, C return, D none of this. So I have told that whenever we want to insert an element to the stack, then it will be incremented. That is, the stack pointer has to be incremented. And this operation is called push. And whenever we want to retrieve an element from the stack, then after retrieving the element, the stack pointer has to decrement by one position or that position. Then it is called, or that operation is called pop. Okay, so I'll just demonstrate this anyways. That is the push operation I'm going to demonstrate first. That is, this is my stack memory, which is having data, say 1, 2, 3 till now. And these are the vacant spaces. Okay, so I'm going to demonstrate push operation. I'm going to insert a data. This is my data to this particular location. Okay, so my stack pointer was earlier at this location. So in order to insert this is my stack pointer. So this stack pointer has to be incremented by 1 before inserting this data. Okay, so now the stack pointer is pointing to this location and then the data is inserted to that location. And this operation is called push. Now, what is pop? 1, 2, let this be my data. I have to retrieve this data. Okay, so in order to retrieve this data, what will happen? First the data is retrieved, then after removing this is a vacant space, right? So the stack pointer has to point to the next valid location. So which is your 2. Because till 2 the data is present now, because we have removed our data. So now it is only 1 and 2. So the pointer has to be decremented by 1 and it will come to this location. Okay, so this operation is called pop. So which is the incremental phase now? This is the incremental phase, because here we are incrementing the stack pointer. That is a decremental phase of the stack pointer, where we are decrementing the stack pointer. Okay, so we can remove n number of datas, but the incremental phase is push and the decremental phase is pop. So the correct answer for this question is option A, which is push. I hope this push and pop concept is clear to you. Anyways, these are the questions which I have included in this video. I hope this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with your friends. If you want to see more videos, please do subscribe to the channel. Thank you.